assumption. There are, as we said at the beginning of this lecture, we said that all the parametric tests have a set of assumptions that need to be satisfied, and that's their downfall. All right, there's quite a few assumptions, and sometimes they can be difficult to satisfy. Now this one is not. This one says the dependent variable was measured on an interval or ratio scale. Aha, this is coming back to bite you again, right? I tried to warn you that you can't forget stuff that you learn early in the semester. So we learned about the scales of measurement: nominal, ordinal, interval, and ratio. So if you don't remember what these are, now is a good time to go back for a refresher. Okay, so we know that the dependent variable then has to be measured on an interval or ratio scale. And we just design our study or experiment so that that is true. All right, we can easily do that. Second assumption, it really doesn't matter which order you go in here, but this is just the second to appear on the slide. The dependent variable is normally distributed in the population. All right, now that is the full assumption. It's not enough to say the dependent variable is normally distributed. You have to say the entire assumption. You have to add in the population. Similarly, up here, you can't just say the assumption is interval or ratio scale. You have to say the dependent variable was measured on an interval or ratio scale. So please remember to know these assumptions in their entirety, okay? Now, as far as this assumption is considered, we have a way of testing it. Remember one of your first SPSS assignments, I think it was the second one, you learned about Shapiro-Wilks statistic, and that's the statistic that tests whether or not your data is probably normally distributed in the population. Now, it's not a hard test to conduct, especially, with SPSS, right? It's just a couple of clicks. But usually we don't test this assumption. We just assume it's true, unless we have good reason to assume that it's not true, right? And that's because virtually all variables, the ones that we're interested in psychology, pretty much most of them are normally distributed in the population. And we just have determined this through many tens of thousands of experiments. All right. The third assumption is that participants were randomly selected from the population. Now, remember, we have to accept a very loose definition of random, because it's almost never the case that everybody in your everybody in your population has an equal chance of being included in your sample, right? How often does that happen? So what we use is something called convenient sampling, which means that we randomly sampled, but it was from the people that we had easy access to. And we call that convenient sampling. All right, now these three assumptions are so important that we're going to refer to them as the core. And when I say that, the core, I want you to know that these assumptions apply to every single parametric test we're going to cover in this course. So the core applies to the one sample t-test, the independent t-test, and the dependent t-test. And the core also applies to all of the ANOVAs we're going to study in this course. All right, so this little mnemonic here will hopefully help you remember what three assumptions are in the core. Now remember, these are just meant to trigger your full recollection of the complete definitions. All right, so if you can just think of the apple core, normal, random, interval, ratio, then that should, again, hopefully trigger your memory for these definitions. Now, what happens if we violate one or more of these assumptions? In other words, what if the assumption is not true? We have a violation. Then remember, technically, going by the book, we would run the non-parametric equivalent. There is an equivalent test for the one sample t-test. For the independent t-test, the dependent t-test, there is a non-parametric equivalent for each of those tests that you could run. But remember, we don't want to if we can avoid it. And that's because if we do run the non-parametric test, there's a chance that our significant result with the parametric test might go away when we run the non-parametric version.